Hello everyone, and welcome to this series about data mining. This is part 3 and it's about Twitter API. We'll be using Twitter API with the Tweepy library to perform basic data mining operations. So the first thing we'll have to do, we'll cover how to get a Twitter API key. We'll get the key from apps.twitter.com. So let's start with that. In here I created an app called Tweepy Tutorial, so we can do that. You go to keys and access tokens and copy your consumer key in here. I will put this key in my consumer key and I will get my consumer secret and I'll put it in consumer secret. Now we will start by importing the library. I'm importing Tweepy, Pandas, and Matplotlib. I'm configuring Pandas to my display. And now the first thing you need to do is to authenticate yourself with Twitter. So I'm passing my consumer key and secret to an OAuth handler, Tweepy OAuth handler, and I'm passing two parameters here, consumer key and consumer secret. Then I'm creating an API object and passing my authentication to that API object. We'll be covering REST API. Notice that Twitter has two APIs. REST API is for requesting existing data, and they have streaming API that returns live stream data. So it will return tweets as they are sent. We'll be covering one function only, which is search, API.search. It receives Q as in query, language, local, RPP, results per page, since ID. This limits tweets only that was sent after a specific tweet ID, geocode, show user. But we'll take a look at the most basic thing. I will be calling search function with q equals IPython. So I will be looking for tweets about IPython. And I'm storing my results in a variable named results. Let's inspect our results. We received by default 15 results. And here I'm defining just a simple function that will return screen name, username, and created at the time the tweet that was sent. So it's just an easy way to look at a certain tweet. So let's start by printing the first tweet we have in our list. We have this user, that's his name, and the tweet was sent just a second ago actually, and it was a retweet from this user, and that was the text inside the message. So let's inspect this object. This it's called the status object. A tweet object is called the status object, and it contains the tweet, user, and multiple other things. So let's take a look at this first. In fact, let's take a look at the same tweet that was sent. In here, I'm just going using this function dir. It will list everything inside this object, and I'm looking for object that does not start with an underscore, because usually they're hidden objects that we don't need. First, I have an author, and it's an object. It's a user object. We'll be looking at user objects in a second. We have created at. This is the time that tweet was sent. We have a method in here that we don't really need. Entries is really interesting because this is where you get the most useful information from the tweet. Symbols, it's like heart symbols and things like this, and emojis. Um, Users mentioned. This will um, return a list of any user that was mentioned in the message. It will return the user ID. It will tell you the indices where the username appeared in the message. The ID in a string format that we don't really need. Screen name. This is the screen name of the person that was mentioned. And that's his name, Titus Brown. There was another user mention, and finally can see any hashtags if there are any hashtags, and you can also see if there were any URLs inside this tweet. So we can see that we have one URL. This is the URL, and this is the expanded URL. So Twitter always shorten all URLs to Twitter format. Favorite count. This will tell you how many times this tweet was favored. This is the ID of the tweet. Language. What are the other important things? Yeah, we have retweet count. So this tweet was retweeted 17 times. And source. We can see what kind of application sent this tweet. So it was sent using Twitter web client. So someone sent this tweet from just a browser. Then we have the text of the tweet inside a variable named text, and the user that sent the tweet. If up to my knowledge, user and author are the same thing. I couldn't find any differences between them so far. Anyway, if anyone knows the difference, just let me know in the comment section below. So let's inspect the user object too. So I'm inspecting author. You can see the user created his account back in 2008. Description of the user. We have a URL that the user mentioned in his profile. Favorites count. This is how many times the user favored a tweet. Followers count. So 2,000 people are following him. Good for him. Friends count 2,100. The user ID. Language. There are other important things. Location is interesting. Name, and some other things. Screen name is the username. Status count. This is how many tweets did the user send, and time zone is by far the best way to determine someone's time zone, or at least some kind of a location, because usually people can write anything like this user location where science happens openly. So I guess that's Berlin. This is the UTC offset, so you can measure how many hours between UTC and the time zone the user is in. And verified will tell you false or true according to if the user was verified or not. Now we're dealing with a small number of tweets. We have 15 tweets in here because it returned 15 tweets in this page. But usually we will be dealing with more than that. We will be retrieving, for example, in here, 100 items. So the latest 100 tweets with the word IPython. So let's do that. And to do that, I'm just looping. I'm using cursor. Cursor is a very useful object to for pagination, basically. So it will iterate all the items in multiple pages. So I can it finished retrieving the data, and it put it in a list called results, and I'm printing the length of this list, and it has 100 items. In here I'm defining a simple function that will basically take a list like this and returns data frame. So I'm returning the text created at, retweet count, favorite count, the source, which is the application used to send the tweet. I'm processing also some user data. I'm getting the user ID, screen name, created at. This is when the user created his account. And you can see that I'm just retrieving all these results using loop comprehension, and I'm finally returning this data frame. Let's call it for our current results. If we'll see the first 5 tweets, we'll see ID text created by the same columns that we just processed. And let's take a look at the last 5 tweets, and we can say the same thing in here. This is interesting, actually. Sometimes in a single minute, more than 1 tweet about IPython is sent, which is good, actually. So let's visualize something about this data. I will be visualizing the source, so which app did people use to send these 100 tweets. I'm using value counts to count how many values appeared in each source, and I'm getting the top 5. So I'm getting from 0 to 5. This is the top 5 application used, and I'm sorting them in reverse direction, basically. In here I'm plotting it in with a horizontal bar chart. Let me show the chart so it's easy to understand what I'm doing here. I'm passing just a list with 0, 1, 2, 3, 4, 5, and these values, how many tweets were sent from each source. Then I'm using ytext to put these labels. So we can say in here that Twitter web client is the most popular within these 100 tweets. iPython iPhone come in second, Android come in third, TweetDeck fourth, and Twitter for iPad fifth. So these are interesting results to know about people who are tweeting about IPython. This tutorial is available in open source on GitHub, and it's viewable on MBViewer. The link to this is in the description below. Thank you for watching, and I hope if you like this, you will subscribe to this channel, and you can watch the previous part of this series about data mining YouTube, or the next part about data mining Google search. Thank you for watching.